to review factoring, and that we would be factoring this next couple of days a lot. So 5.4 and Chapter 5 in general, the parts that we're going to focus on are rational expressions and equations. We're going to be graphing rational functions. But today is simply multiplying and dividing expressions that are rational expressions. And a rational expression is simplified if its numerator and denominator have no common factors other than plus or minus 1. So we are going to be working on multiplying and dividing and simplifying rational expressions. And you'll know that you're done when there are no common factors between your numerator and your denominator, which means you're going to have to factor your numerator and your denominator. So the steps to simplify, very first thing that you're going to do is you are going to factor the numerator and denominator. Can't spell denominator. No. There we go.
It's all right.
I still need to model good behavior. All right, so first you're going to factor. When we're dealing with rational expressions, what kind of expressions are we dealing with?
Rational.
What's rational mean? Can be written as a fraction. So we're dealing with fractional expressions that are going to have polynomials in them. So we're dealing with a polynomial over a polynomial. When we're multiplying them, we're going to be multiplying rational expressions, which means we're really simply multiplying fractions. When you multiply fractions, what do? Multiply straight across. Your numerator and your numerator, your denominator and your denominator. So before I go any further, I just want to make sure you remember basic fractions, which we worked on so much last semester. If I had something like 2 over 7 times 49 over 8, should I multiply straight across? Okay, you should cross cancel first. Don't multiply straight across, okay? So 2 and 8 would reduce to 1 and 4, 7 and 49, 1 and 7. Then multiply straight across 7/4. Okay? So cross cancel if possible. When you are dividing with fractions, what are you really doing?
Multiplying by the reciprocal.
Multiplying by the reciprocal. So today's lesson is simply going to be multiplying and dividing with fractions, except they have polynomial expressions in them. So we are going to be factoring and cross-reducing or reducing across any numerator, any denominator. Okay? So we're kind of combining our ability to multiply and divide with polynomials and fractions. So step number 2 is simply to cancel any common factors. And then I'm going to let you leave answer in factored form. I do not want you to multiply it back out because number 1, that's a lot more work. And number 2, if we all do the same thing, that makes life so much easier on me when I'm grading. So I'm going to let you leave your answer in factored form so that you don't have to do extra work, okay? Not granny, on grading. That's funny. All right, so first we're just going to start with an expression that we want to simplify, and then we'll work our way, as you can see, to multiplying, and then eventually to dividing, okay? So start with this first one, and we want to factor. What can I factor in the numerator? GCF, x. Always look for your GCF first. What does it leave me with? X plus 7 over x squared. You can rewrite x squared as x times x if it helps you. What can cancel? Okay, one of the x's in the denominator with the x in the numerator. So what am I left with as my answer?
X plus 7 over x.
X plus 7 over x. Can I cancel out those x's? Good. Remember that x plus 7 over x means that the entire x plus 7 is being divided, and that means that this is basically in its own set of parentheses. An order of operation says you have to work inside the parentheses before you can divide. So number one, that's why you can't cancel it. Number two, if we really were going to separate this apart, it would be written as x over x plus 7 over x. Both of them would have to be divided by x in order to have a common denominator that would allow you to add the numerators. So if you just cancel out the x's, you're saying your answer is 7, when really it's not. It's 1 plus 7 over x. Does that make sense? Okay, so don't do that. All right, go to the next one. We have polynomial expressions in both top and bottom. They are trinomials, so we have to remember how to factor. I hope that you remember how to do guess and check, because it's probably going to be the fastest. If not, you're going to be working a whole lot of box methods or whatever method you chose. How does the numerator factor? X minus what? X minus 4, quantity squared. So x minus 4 times x minus 4. You can write it as quantity squared. You need to if that's how you leave your answer. But there might be an x minus 4 in the denominator that's going to cancel. So I'm going to leave it like this for now. What's the denominator factor into? X plus 6 times x minus 4. And then we do have an x minus 4 that can cancel. So then my final answer is just x minus 4 over x plus 6. That's it.
Okay, this is not.
Okay. Go ahead and go to the next one. Does the chapter get harder? Probably. Does this lesson get harder? Not much. The problems will get a little bit more complex, but it's the same process. Okay? All right, so look at the next one. We're multiplying now. To multiply, we multiply straight across, but remember we want to first try to cross cancel. Simplify as much as possible. Any numerator with any denominator. So I'm going to start with my numbers. What can I reduce here with my numbers? 8 and 4. So 8 goes into itself, or 4 goes into 8 twice, and 4 goes into 4 once. What else can I reduce? Just my numbers first. Nope. 2 and 2. You've got a 2 in the top and a 2 in the bottom. It doesn't have to be in one numerator and in the opposite fraction's denominator. Any numerator can be reduced with any denominator. So my 2's can cancel. 2 over 2 is just 1, right? Okay. Everybody with me there? All right. So I'm going to go ahead and cancel those. Now, what's our rule for dealing with exponents? For multiplying with the same base, you add. If we're dividing with the same base, subtract. So we can reduce this first fraction if we want to by using that property. So x cubed over x becomes x squared. Y over y squared becomes y to the negative 1. So it's going to be in the denominator. Is it okay if I just simplify that down? Okay. Times. Now let's simplify the next one. And again, our 2's had canceled, so we don't have a number here. Looking at the blue part, 7x to the 4th, y squared. Good. Is there anything left in the denominator? No. Now we can cross-reduce or cross-cancel if we want to. So I have a y squared in the numerator and a y in the denominator. So this is going to cancel, and I'll just have y to the first power. And so now we can multiply straight across. Did I lose your back, son? Okay. And since we're multiplying with the same base, we add. So what is my final answer? 7x to the 6y. Is that it? Okay. And if you wanted to multiply straight across first and add your exponents and then subtract, that's fine. Whatever works for you.
Why did you cross out the 2?
Because, oh, here?
Yeah.
Because I had 2 over 2, and 2 over 2 reduces to 1. So I just canceled out my 2's.
Could we also
Okay.
cross-cancel the y's at the beginning?
Yep. We could have cross-canceled the y's in the beginning. So if you wanted to do that to start with, you could have. So x squared times x to the 4th, we add the exponent, so that's x to the 6th. There is no y left except this one, so I have a y there. This y and this y squared Canceled because I have two y's in the top and one y in the bottom. There's no plus or minus sign, so you're not distributing. Distributing occurs when you have a plus or a minus. You're just multiplying straight across from left to right, same base, add your exponents. Did I lose anybody else there? Okay, go down to number 4. So what do we want to start doing here? Factoring. I'm going to start with the first fraction, numerator only. I can pull out my set of 5x, GCF. What's it leave me with? 4 minus what? X. Okay, somebody different. What can I factor out of the denominator? X. What does it leave me with? X minus 1 times, I'm going to come over here. Now I'm working with the second fraction. Numerator only. Somebody different. How can I factor the numerator? Harkus, you may need to stand up today. Cesar said x plus 4, x minus 1. You guys agree? All right, denominator. Difference of 2 squares. Good. And I'm going to write that formula on the board in case you have forgotten. A squared minus b squared factors into a plus b times a minus b. Does it matter which order I write those? No. You can do a minus b times a plus b. All right. Is there a sum of 2 squares? No. So this factors into what, Megan? X minus 4, x plus 4. Catherine, question?
I changed the 5x to the 4 minus x to negative 5x times x minus 4.
Good.
It's not negative x plus 4.
Good. And we'll come right back to that, Catherine. Before I explain what Catherine just said, in case you didn't catch that, what can I cancel here? The x plus 4 is over here. What else? X minus 1. Remember, any numerator can cancel with any denominator if you are multiplying. Only when you're multiplying. Anything else I can cancel before we talk about the x minus 4? Yep. What else can I cancel? The x. I have an x in the top and an x in the bottom, so those x's can cancel. Is that okay? All right, now, what that would leave me with is 5 parentheses 4 minus x over x minus 4. But Catherine said, notice that these almost look the same. If I rearrange the top one so that the x is first, it would be negative x plus 4. Would you agree?
Yes.
So what could I do to negative x plus 4 to make it x minus 4? Take out a negative. So we're going to factor out a negative, which is going to change that to a plus x minus 4. So that this is the same as negative 5x minus 4 over x minus 4. Anytime you have a factor that looks the same, but the signs are in the wrong place, you can take out a negative and it'll change both of your signs so that they are identical. So now we can cancel out the x minus 4's. And that means our original problem, number 4, is equal to negative 5. Isn't that exciting? I don't know, but it's so fun. Any questions?
It's perfect.
You know, I'm having a good day today. It'll be a bad day tomorrow. Tomorrow looks like a square, but we'll go with it. Yeah, give him time. Number 5, let's go. Multiply. Numerator, I'm going to call on some of you. Danielle, can I factor anything out of my numerator? Be careful. Good look, but what were we missing there? The square on the x. So nothing factors in our numerator. What is the denominator? Difference of 2 cubes. Let's remember our formula for that. A cubed minus b cubed. What does that factor into? A minus b. A squared. Okay, and is it Shara and Chloe that keep writing soap on their paper? Okay, it took me forever. I think I actually asked Spencer, and then he finally figured it out for me. I had never seen that before, but that is awesome. SOAP, meaning that we want the same sign, correct? And then opposite sign, and then always positive. So it always ends in a positive. So when you're doing sum or difference of two cubes, when I get sum of two cubes, I'm going to have a same sign plus b, opposite a squared minus ab, always positive, plus b squared. Okay? I was like, that's awesome. Good job. Questions there? All right, so those are our two formulas that we needed to remember. So we come down here to the denominator, number 5. And Braxton, can you factor number 5's denominator for me?
5 denominator. X minus 2, and then x squared plus 2x plus 4.
Very good. And remember, when you do sum or difference of two cubes, it is completely factored. You do not have to look at this trinomial and see if it'll factor further. It will not factor further. This is as far as it will go. And then we have this times numerator. Can I factor that? What's it factor into? No? Okay, it does not factor further, so we leave it as x squared minus 2x plus 4 over 1. Can we simplify anything? No, nothing can simplify. So all we do, we factored all that down, but nothing will simplify. So we just multiply straight across. Do we distribute? No, because what did I tell you at the very beginning? We're going to leave our answers in factored form to make our lives easier. So you do not have to come down and multiply that all back out. You're just going to write x minus 4 times x squared minus 2x plus 4 all over. You do need to combine it. You do need to actually show that you've multiplied and it's all one fraction. X minus 2. Good. Times x squared plus 2x plus 4. And circle it. There was nothing that could reduce. Alika. How would that factor? It doesn't factor. If you try to factor x squared minus 2x plus 4, factors of 4 are simply 1 and 4 or 2 and 2. And there is no way to take 1 and 4 and 2 and 2 and get a factor of negative 2 in the middle, no matter how we combine that. But we're not doing quadratic formula. We're not trying to solve. Yeah. Correct. You're right. Except if we wanted to check, we could check our discriminant, b squared minus 4ac, and see that it's not going to factor down. Are you with me, Alika? All right. So if it would have factored, yes, we would factor it and try to cancel. But in this case, nothing cancels. And I like that example just because it reminds you that sometimes they're not factorable. They're going to try to make sure you really know what you're doing. Okay? Go to the back side. What's the difference with these two? They're division. So what are we going to do first? Good. Change it to multiplication. Flip it over. So this is now going to be x squared minus 6x plus 8 over x squared minus 2x. Do I flip both of them? No, just the second one. So keep the 4x over 5x minus 20. I'm going to go ahead, set up the next one, number 7, and I'm going to let you work both of them and we'll check them. So what do I do on the second one when I change it to multiplication? Good. It's over 1, so when I flip it, it becomes 1 over 3x squared minus 2x. And my first fraction stays exactly the same. You guys go ahead and work both of those, and we'll check them in a second. Let's go over these. I have not seen... Do you have a joke, Alika? Do you want to test the joke? Oh. Maybe we should move on then. Number 6. I didn't see anybody who did not have 4/5. Anybody not get 4/5? Good. Anybody not at the end? Do I need to go over this? Okay. I'm going to work 7 because I did see several people not finished with 7, okay? So look at 7. How did the numerator factor here? 3x minus 2 and x plus 5. We needed to end up with a positive 15 and a minus 2 to get a positive 3. Or positive 13, sorry. 6x squared still in the denominator times 1 over. How did the second denominator factor? Take out a GCF of x, and we have 3x minus 2. So what could we cancel here? The 3x minus 2's. And what do we get for our final answer? X plus 5 over 6x what? Cubed. Don't forget you have an x squared and an x to the first, so we add those exponents when we multiply with the same base. Any questions? All right, let's look at some geometry. So it says, manufacturers often package their products in a way that uses the least amount of packaging material. One measure of the efficiency of a package is the ratio of its surface area to its volume. And I'm really kind of sad that we didn't get to do it in this class. Miss Layton is getting ready to do that today in our every other day class. We're doing a project where they have to figure out which geometrical shape would produce the most efficient packaging material based on which surface area to volume ratio would be the least. So, three-dimensionally, what do you think it should be? A sphere. Three-dimensionally, right? Three-dimensionally. All right, so the smaller the ratio, the more efficient the packaging. So number 8 says, a company makes kitchen canisters with the same base. Style 1 is a cylinder whose height is equal to the radius. Style 2 is a cylinder whose height is twice the radius. So now we get to go back and think about cylinders and what our surface area and volume formulas were. So volume is what? Base times height. Okay, here's the thing, guys. You all are taking the ACT, and whether or not you remember the geometry or not, you need to. So this is a great time to write it down, to start remembering, to practice. Okay? Surface area. What was our formula for surface area?
Okay, it's the circumference times the height.
So we called that capital P for every prism, but for the cylinder, that's going to be a C for circumference times the height. Plus 2b, good. So I'm going to put, as Catherine said, CH plus 2b because it's really the circumference. Okay? Are we good with that? All right. So part 1 says find the surface area and the volume of each canister. So we're starting with the first one. Draw your picture and put your information on it. So it says it's a cylinder whose height is equal to the radius. So the height is the same as the radius. So what can I call the height? Or R, because R stands for radius. All right. Cylinder 2 has a radius of R, but its height is what? 2R. So it's got radius R and height 2R. And we want to find both the surface area and the volume for each one. So let's start with, I'm going to do the first one with you, and then you can do the second one. Volume, capital BH. How do I find the area of the base? Pi r squared. So it's pi r squared times the height, which is R. And so what's my volume? Pi r cubed. Okay, surface area. Surface area is pH plus 2b or CH plus 2b. How do we find the circumference? 2 pi r. And again, we find the area of the base by doing pi r squared. So now we're going to plug in our R for our H, and we have 2 pi times R plus 2 pi R squared. I'm going to slow down just a second. What's 2 pi R times R? 2 pi R squared plus 2 pi R squared. And what is that? 4 pi R squared. So our surface area is 4 pi R squared. Our volume is pi R cubed. Did I lose anybody there? Okay, you guys do the second canister and find the surface area and the volume, and then we'll compare in just a moment. And guys, again, some of you are quick and remember, and some of you not. So be respectful here real quick. We're going to go over these. If you have it, great. Just be quiet and listen. If you don't, please follow me up here. Volume, again, was capital BH. So we have that pi R squared H. May not be a cylinder on your homework, so you need to remember your formulas for volume and surface area. Plug in your height. Your height was 2R, and then use your properties for exponents. So this becomes 2 pi R cubed. There's your volume. Now we go to surface area. Again, it was circumference times height. Circumference was 2 pi R times your height plus 2 pi R squared, area of your base. Your height, in this case, was 2R. And what is 2 pi R times 2R? 4 pi R squared. Don't forget when you multiply to add your exponents. Plus 2 pi R squared. We both have pi R squared, so what's 4 pi R squared plus 2 pi R squared? 6 pi R squared. Questions on surface area or volume? Okay, before we go on to the second part of the question, remind me, what are my surface area and volume formulas for pyramids or cones that come to a point? Okay, so I'm hearing 1/3 pi R squared, but that would only be for which one of these? Cones. Okay, so it's 1/3 area of the base times the height. What's surface area? Base plus times slant height times, nobody remembers? Okay, but I'm missing something else. So I've heard circumference or perimeter times slant height, but what am I missing? 1/2. So the formula that we learned was 1/2 PL plus B. Okay. Yes. Okay, spheres. I would highly encourage you to add this in your notes if you don't remember. Volume. 4/3 pi R cubed. Surface area. 4 pi R squared. Okay. And a little special one that we talked about, the cube or the hexahedron. So what is the volume of a cube? Side cubed. What would surface area of a cube be? Okay. 6 S squared, because it's 6 times the area of the base. There's 6 squares on a hexahedron. All right. Back to our notes for today, but you need to write that down if you don't remember this. ACT, no formula sheet, right? Calculate. Kick you out and give you a 0, and you just wasted a bunch of money.
That's discrimination.
All right, you ready, guys? Back up here. And everybody with me. Calculate the ratio, Nick. Calculate the ratio of surface area to volume for each canister. So let's start with canister number 1, or style 1. We want ratio, which means what? Division or fraction of surface area to volume. What was my surface area for canister 1? 4 pi r squared. What was the volume? Pi r cubed. And now we use our rules for simplifying. What can I cancel out here? Pi. And what am I left with? Okay, 4r squared over r cubed, but I can simplify that further. So what am I left with? 4 over r. Now, if you are not using r for radius, you better make sure that you are labeling your picture with whatever variable you are using to indicate that you're using a different variable. Otherwise, you should be using r for radius. Okay, let's go on and do canister 2. So canister 2, surface area to volume. What was it again? 2 pi r cubed. Nope, what is my surface area? 6 pi r squared. What's my volume? 2 pi r cubed. So it makes a difference which way they said to write your ratio. What does that simplify to? 3 over r. Pi's cancel. 6 over 2 is 3. R squared over r cubed is 1 over r. Okay, last question. So we have our ratio of surface area to volume, and it's set up here. The smaller the ratio, the more efficient the package. So the last question says, what do the ratios tell you about the efficiencies of the 2 canisters? Very good. Did you guys hear what May said? What do you think May said? Okay, the second canister is more efficient because 3 over r is less than 4 over r, which means that the second canister has a smaller surface area to volume ratio. So your answer should be the second canister is more efficient. Yes?
So if it in reverse or like volume to surface area instead of surface area to volume, wouldn't the first one be smaller because it's over 4 and like 1/4 is smaller than 1/3?
Yes. Very good question. Anybody have a question on the last part? Okay.